Okay, so hello everyone. It's been some time since I uploaded the video. Okay, so that's another story, but like today we are gonna learn something new. Okay, the topic is segmentary. Okay, it's an uncommon topic, but it is important. Okay, so if you like are open to learning new things, then the segmentary is a like it's a I would say a good topic to learn. Okay, so what is segmentary? Okay, so let's just see what is segmentary. Okay, so what is segmentary? See, let me just take an example, and then let me just first build a segmentary, then like uh, we are gonna deep down to it. Okay, so let's take an array 3 4 2 5 3. Okay, so like okay, so before discussing why segmentary and what's the use of it. Okay, what is segmentary? Segmentary, a kind of tree, I would say, but not exactly tree, but like to say why segmentary. Okay, why? Like we have studied many data structures, and each one have use case of its own. So and this is also the same goes for the segmentary also. It has its own use case. So let me just tell you why and when. Okay, these two are like the important things to know before starting a topic. Okay, so why? To efficiently handle range queries. Okay, and when to use it? This is the answer of why. And when to use it? Use it when you need to find maximum, minimum, sum, just okay, maximum, minimum, sum uh, in a range for multiple queries. Okay, so okay, so let's just take an example. It will cover both of the things. Okay, so suppose we have an array. Okay, the array contains element 3 4 2 3 comma 4 comma 2, and we have 3 4 2 5 3 6 3 4 5 3 6 3 4 5 3 6 3 4. Okay, 5 6 5 3 6 3 4. Okay, good. So what will be the indexing of it? It will be 0 1 2 3 4 5 6 and 7. Okay, so suppose there is a let's just say, or let me just take a smaller example, then we can just move to it. Okay, so we're gonna do it later. Okay, So let me just start with a smaller example. Okay, so it's an example number one. Okay, let's suppose we have an array in which we have 1, 2, 3, and 4. Okay, first we need to understand why we need segment trees. Okay, so that's why I'm going with this example. Okay, 0, 1, 2, 3. Okay, now let's just say that there are some queries. Okay, queries. Okay, like find the sum. Uh, find the sum from like range 1 to, let's say, 4. Okay, I'm gonna add some more elements to it. Okay, then like we have 5 and we have, let's just say, 6. Okay, so this will be 4 and this will be 5. Okay, so what can we do? Like we can just simply start from 1 and like we can calculate like 1, 2, 3, and 4. Okay, so like this will be the first approach. Okay, this is the first approach. Okay, simply iterate. Okay, and it will take the time complexity of big O of n. Okay, uh, is there any other approach? Yes, we do have. Okay, uh, we can do prefix sum, right? Second approach, we can use something like prefix sum. Okay, so what will be the prefix sum of it? It will be uh, this will be 1, this will be 1 plus 2, 3, 3 plus 3, 6, 6 and 10, 15, 21, and like the answer if you calculate 1 to 4 is 2 plus 3, 5. Like this is the one. So 2, 3, 4, 5. So this will be 5, 5. It's 14, right? No, wait, just, yeah, it will be 14. Okay. So we can just, so by like using the prefix sum, we can just use ARR of like the 4 minus ARR of 0, which will also give us 14. Okay, so this is a much better solution. Okay, so we can do things, okay, like this way also. Okay, so like suppose if there is a query, we're gonna come to the segment tree in like very slowly. We are gonna come to it. Okay, like find the max in range of 1 comma 4. Okay, so in like I think that in this case the first approach will work, like the iteration one. First approach, which will gonna take big O of n, right? Okay, so and what else can we do? We can simply like if it's a maximum or minimum, this will happen. Okay, so there can be also question on queries, or like queries can be like add plus 2 in the range of 1 comma 4. Now you have to go uh, in a you have to go iteratively. Okay, so this will again gonna take big O of n. Okay, and there can be a query uh, there can be a query in which like uh, update the value at index update the value at index 1 to 10, right, to 10. Okay, and then return the range sum or something. So this is gonna take again big O of n. Okay, so in these kind of cases we are seeing that for the each query in like most type of the queries we are gonna taking big O of n, right? Okay, so in order to optimize this we use segment tree, which will gonna solve our problem in segment tree. Will gonna do it. Segment tree is gonna take big O of log n, right? And this this one. Okay, so this one is a very important topic of lazy propagation. Okay, like I'm gonna make a video about it also. Okay, propagation. Okay, this is a part of lazy propagation. Okay, so uh, it's very useful, right? Because we have optimized it from n to log n. Okay, so now let me just show you what is segment tree. Okay, so we have taken the element 1 2 3 4 and 5 6. Okay, so like suppose there are the elements 1 2 3 4 5 and 6, right? Okay, so what is the range they are representing? It is representing 0 to 0, it is representing 1 to 1, similarly 2 to 2, then we have 3 to 3, 4 to 4, and 5 to 5, right? So right, okay, okay, so we have written it correctly. Okay, let's just say we need to find the sum of a range. Okay, so we are working for the query, let's say, or we can just take like say the maximum in the range. Okay, maximum in the range. Okay, uh, what should we store? We can either store the index or we can store the value. Okay, so let's just go and store the value. Okay, like for the understanding purpose, storing values for the range. Okay, so if we're gonna build it, okay, so segment tree goes upward. Okay, so let me just move it down a bit. So like what is the maximum between 1 and 2? It's 2, right? Now what's the range? 0 to 1. Okay, tell me what is the maximum between 2 and 3, 2 to 3? like what's the maximum between 3 and 4? It's 4, right? So 4. So what is the range? It's 2 to 3, right? It's 2 to 3. Then what is the maximum between 5 and 6? It's 6, right? So it will be something like this. So the range will be 4 comma 5. Okay. Now like okay, so I think that I should add two more elements to it, because like there's a reason that I will be explaining in the later part. Okay, so it's 7 to 8, then we will be having 8. Okay, like for the symmetrical purpose I am doing it. Like I will tell you why we are doing it. Okay, so this will be like 6 to 6, and this will be like 7 to 7. So this will be like 6 comma 7. Okay, now what is the maximum between 2 and 4? It's 4, right? It's 4. And what will be the range? It will be 0 comma 3. Okay, I think we are getting it. Okay, so and like what is the maximum between 6 and 8? It's 8. Okay, so it will be something like this. And what will be the range? It will be 4 comma 7. Okay, now if we like take the maximum of these twos, it will be 8, right? And the range will be 0 to 7. Okay, so this is now what a segment tree looks like. See, from 0 to 1 we have the maximum, which is 2. Okay, so let me just write the elements, which are 1 2 3 4 5 6 7 and 8, and these are its indexes, which is 0 1 2 3 4 5 6 and 7. Now how we gonna solve it? Okay, so suppose there's a query in which we have like the max in like say 4 comma 5. What is the maximum? Okay, or like say what's the maximum in 4 comma 7. Okay, so as you can see, the maximum in the 4 comma 7 is 8, right? And if you're gonna see it, you will find out like 5 6 7 8, and 8 is the maximum. Okay, so the tree will look something like this. Okay, it has its internal implementation. Okay, it's like it's a complete binary tree. Okay, complete binary tree represented in represented in like in the form of array of array. Okay, so yes, this is how we're gonna do it. Okay, so like the size of the tree, like the array, will be 4 times of the n. N here is the number, like the size. N is the size of a of the array. Okay, so like this let me just take another example, like a smaller example, to show how the things are built. Okay, so suppose like we have 1 2 3 and 4. Okay, so 2 is the maximum. Here we have 4 as the maximum, and we have 4 here. right? Okay. Like, if we are writing the range, it is 0 to 0. It is 1 to 1. See, like why I'm not making this one, because this will be a bit of a, like it will be quite messy, and it doesn't matter how much big like the how large tree I make, you won't be getting it if you are not doing it by your own. Okay, so you should be practicing it by yourself. Okay, like if you want a bigger diagram, you can do it. Okay, we're gonna solve it like do it recursively. Okay, so and like this will be 0 comma 1, and this will be 2 comma 3, and it will be 0 comma 3. Okay, so okay, what is the size of this array? Okay, so the array is 1, 2, 3, and 4. Okay, indexing wise it is 1, 2, 3, and 4. So this is how it will be. Now the segment tree will be of the size 4 times, which will be like 0 to 11. 0, 1, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Like suppose the initially the value will be all zeros. So what should we do first? Should I write the code first and then do the try run? What should we do? I think that we should write the code of it first. Okay. See, what do we have? We have this. Okay. From this, we need to fill this. Okay. So let's just start writing the code. Okay. Like suppose there's a function which is a bit. B tree means build a tree. Okay. In this, we're gonna first pass the index, then we're gonna pass the range, okay, which is with the L, and it will be the R. Okay. Then we're gonna pass the array, and then we're gonna pass the segment tree itself. Okay. Now, how will this be called? In what manner? It will be called in like this way. Okay. B tree 0 comma 0 to n minus 1, and this will be our ARR, and this will be the ST. Okay, so before moving forward, let me just tell you this, that the IDX represents the IDX represent the index of segment tree. It's not gonna represent the index of array, it's gonna represent the index of segment tree, and L and R are the ranges. Okay, it's left and the right. Okay, so what we're gonna do is like just call these two for the left and the right part. Okay, so if I'm gonna call B tree of 2 into idx plus 1 for the left part, right? We are building. Okay, so like for the left part we're gonna do it like this, and for the right and like the, okay, so before, like, see, it's a binary tree dividing into two parts in two ranges. Okay, so we're gonna also need to find a mid. Okay, just a second, just let me just move it up, or let's just move it. Okay, so I'm gonna find mid, which will be L plus R by 2. So what we are going doing is that we are dividing it into two parts, right? That's what we did. Okay, so bt, it will be 2 into idx plus 1 comma l comma mid, and like it will be arr, and it will be the segment tree itself. Okay, so what we just did, that we passed this, that you make a segment tree by yourself, that what the Gaussian do, and we're gonna do 2 into idx plus 2 mid plus 1 into r arr of st, and you build the segment tree of your own. Okay, so this is how the segment tree will be built. Okay, it will go on and on. Okay, let me just do it for this part. So 0 comes 2 into I plus 1, which will be the 1. Okay, and so this will be built and this will be built. So now we know that the segment tree is filled in the later part. Okay, so now we check if, like, the, okay, so now we're gonna check that the value at the segment tree of 2 into I plus 1, if this value is greater than or equal to ARR of ST into, like, into 2 into I plus 2, then what we are gonna do is that we're gonna fill it with the segment tree of, what should we store. Okay, so we were storing the value. Okay, so like, we don't have to do this. Okay, this will be for the index part, but we are not storing the index, we are storing the value itself. Okay, so it will be something like this. Okay, so yeah, it will be having the value which is the segment tree of 2 into I plus 1, and we're gonna close it, and else part, we're gonna update st of I equals to st of 2 into I plus 2. So this will be the code, and we didn't write the base condition yet. Okay, So what will be the base condition is that if L equals to R, which means we have a single element left. Here L equals to R. See, here L equals to R, here L equals to R, and here it will be L equals to R, right? So here what we will be having is that we will be having the value which like we are only having a single element left. So here we are going to store the ARR of L, or we can also store the ARR of R, and we're gonna just return it from here. Just a second. I'm gonna just return. Okay, so that's how our segment tree code will look like. Okay, so this is the code. Now let's just a second. Okay, so like yeah, let me just show you something. Okay, so this will be at the zeroth index of this segment tree. Okay, so how it's gonna flow? See, here we have 0, so 2 into 0 plus 1, so this will be at the 0th index. This is the left node and it will be at the first index. Okay, left to it we have 2 into 1 plus 1, so 2 into 1, 2 plus 1, 3. So this will be at the third index. Okay, so what I'm saying that this will be at the third index. So when this is at the third index, we are going to fill it. So will it have 1 here? Yes, it will have. Okay, we're gonna move back. We come here and 2 into I plus 2. What it will give? It will give us 4. And this will be at the fourth index. Okay, so this will be at the fourth index of the segment tree. Now we're gonna move back and we have like at the first index. Now we have come back to the first index. Okay, for this we have returned. Now when we are standing at the just a second. Now when we are standing at the first index, what we are doing? See, this call has been made. This call has updated the and third index, and this has updated the fourth index. Now we come back to the first call. Okay, so we are gonna talk about zeroth call also, but we are moving like I'm showing you how to like how it's happening. Okay, so standing at the first index, we are taking the maximum which is present at its left child and its right child. So at the first index, if we are standing, so the segment tree of 2 into I plus 1, if it's greater than or equal to segment tree of 2 into I plus 2, so like what is the value? This will give us 2 into I plus 1, which is 3 obviously, and this will give us 4. So at the segment tree of third, what do we have? And the segment tree of 4, what do we have? At third, we have 1, right? We have 1. and like we have 1, and what do we have here is, what do we have? We have 2. So at this index we will have 2, right? Now we're gonna move back again, and then we're gonna call for this. So 2 into 0 plus 1. Now we are at the, okay, just a second. 2 into I plus okay, it's not 1, it will be 2. Okay, it will be 2. So this will be the second index. Similarly, 2 into 2 plus 1, which is 5, and this will be 6, right? Because 2 into 2, which is 4 plus 2, is gonna be 6. So at the fifth index we will be having 3, and the sixth index we will be having 4. So like while standing here, if we're gonna check the left child, which is 3 and 4, we will be having 4 here. And when we are standing at the 0th position, so 2 into 0 plus 1, which is 1, and 2 into 0 plus 2, which is 2, what's the maximum at these two positions? At 1 we have 2, and at this we have 4. So this at like this position, like the 0th position, will be having the 4. So this is how a segment tree is being formed. Okay, this is the code, right? This is the code, and like this is it, it's how it will be written. And I don't think that only the initialization part, how will you initialize in the int, like in the main function, we are gonna have like a suppose vector int arr, and we'll be having some values. We will be having n, which will be having the arr of size. Okay, so if we're gonna initialize the segment tree, it will be like 4 into n comma 0. Like this will be the initialization, and how we call it here, bt of like the bt of 0 comma 0 comma n minus 1 comma arr comma st. This is how the segment tree will be built. Okay, so this is the building part. Now how we gonna access it? The same way. The same way, I mean that let's just say, uh, let me just draw it again. Okay, so the things will be much more clear. Now let's just suppose you have a segment tree, you have built a segment tree which looks something like this. This is 2, this is 4, this is gonna be 4, and like the ranges will be 0 comma 0, 1 comma 1, 2 comma 2, 3 comma 3, and it will be 0 comma 1, it will be 2 comma 3, and it will be 0 comma 3. Okay, now we can just access it in the same 0th position. Let me just use a different color, it's not that good. Okay, so 0th position, right? Okay. What should we do? Which range? Let's just cover 2 comma 3. Start from 0th index. How we're gonna flow is that we're gonna go here and see. We're gonna, the range is 2 comma 3. Okay, does 0 comma 1 lies anywhere in our range? So we can just simply return back, and we're gonna go here. Now we see just 2 comma 3 like 3 lies in a range. Yes, so this is our answer, but I think the quote, like the, it should be a bit big of an example. So let me just add the elements. Okay, so it's like 1 7 2 6 3 5, and we have 4 and 8. Okay, so this will be a good example. Maximum, we are taking just the maximum. Okay, and here we have an 8. Now what will be the range? It will be 0 comma 0 1 comma 1 2 comma 2 3 comma 3 4 comma 4 5 comma 5 6 comma 6 and 7 comma 7. Now talking about this range, it will be 0 comma 1 2 comma 3 4 comma 5, and we're gonna have 6 comma 7. Now again moving upwards, 7 will be our answer, so the range will be 0 to 3, and like for this 8 will be the maximum, so it will be like 4 comma 7, and this will be 8, which will be 0 comma 7. Now uh, let's just say we need to find the range is like the range is of 4 comma 5. Okay, so now tell me how we are gonna do it. Starting from here, let's just go to left, like 0 comma 3. Can we take something from here? No, it's completely out of our range. Or let me just modify the range. Uh, or let's just solve it for the 4 comma 5, and then we're gonna take another example. Okay, so let me just copy down the tree so that I don't have to draw it again and again. Okay, okay, now now we can do it. Okay, so tell me 0 comma 3, it's not in a range, like it's completely not in a range. We can go back. Okay, 4 comma 7, it's somewhere in a range but not completely. Okay, so let's just move. 4 comma 5, it's completely in a range, and 5 will be our answer. Okay, so this one was also in a straightforward, but now let's just say we are having a range which is from 2 to 5, 2 comma 5. Now see what's gonna happen. We're gonna go here 0 comma 3, like it's somewhere in the range. Okay, now let's just explore the left part first. 0 comma 1, no, not in a range, completely out of range. We're gonna go back. Now we're gonna come to the right part. 2 comma 3, somewhere in a range, not completely. Okay, we are gonna go here. Now when we come to 2 comma 2, yeah, it is completely in a range, so we do consider it. maxi is like first initially it was 0, now it's 2. We're gonna go back, we're gonna go 3 comma 3, or oh, just a second, I moved one step further. Okay, sorry for that. Now when we come here, 2 comma 3, it's completely in a range. Okay, I like moved forward, it's completely in a range, so the maxi will be initially 0, but now it will become 6. Okay, we got, go back, come to 4 comma 7. Is 4 comma 7, is it in a range? Not completely, but some part is in the range. Okay, now we're gonna go left. 4 comma 5, is it in a range? Yes, it's completely in a range. So the maxi will still be remaining 6 because 6 is still greater than 5. So that's how the recursive call will be made. Okay, so it's a very easy part. Okay, so what its function will look like. Suppose the function name is, let's say it's fun. We'll be having like the okay. What we will be having is an I, and what we were taking, L comma R. Okay, L comma R. This S is the starting. We have an ending like the range, and or let me just write it afterwards. We were having array. We were having an segmentary, and or I don't think that we need to take this array anymore because we aren't using it. Okay, we only need segmentary. Okay, now we will have an starting, we will be having an ending, and we will be having a maxi. Okay, what we were just doing, we're gonna cite the same thing. If not completely in our range, we're gonna return. Okay, so this will be the same. If L is less than the start, and like the R is also less than the start, it means it's completely out of range, like on the left hand side. Okay, and if L is greater than R, and or oh, okay, it will be the end. uh, Sorry for that. If it's completely out of the end, like the right hand side, it's end. Okay, or like if the R is completely greater than E, we are gonna just simply return. Right, right, that's what we were doing, right? We were simply returning. And if it is completely in a range, start, and like the R is less than equal to E, which means it's completely in a range, then we can just calculate the maxi equals to maximum of maxi comma segmentary of I, and we can return from here, right? That's what we were doing, because if you got the answer here, like you got the answer here, you don't have to go left and right because you got the answer, right? Similar, if you even go, you will still get the same answer. Okay, so it's not worth of going. Then just find the mid and make the function calls, right? The function calls will be made, and yeah, so you can code it up, because like I have written this entire pseudo code, so I don't think that I need to write it, but I have written some code, but so I can just do the try run for it. Okay, so me just zoom it. And yes, see what I am doing here is that I have taken an array and using the segment tree. Okay, so it's a lazy propagation question, but you will get it. Okay, this is the same thing which we were doing to do the build tree. In the build tree code, we have added just 1 to 2 points, okay, in which we solved it. Okay, so that the basic code of all these problem is the same, only there's a bit of a change. Okay, so the questions are not that difficult. It's only about the implementation part and understanding the tree. Like, if you can see, like, imagine this tree, draw this tree by yourself. Okay, I'm not telling you to draw this segment tree array. No, build this tree, right? If you're gonna build it, you're gonna imagine it, and then you can definitely code it up. Okay, so yeah, that's all for this, like the concept of the segment tree. We'll be solving some questions on it. Okay, so I'll be uploading it soon, like as soon as possible. So yeah, that's all for this, like the concept clear thing. So yeah, thank you everyone. Have a nice day ahead.